Hi, Trig students. This is our very last section of material for the class. We don't have to worry about 10.7 this semester, so we are going to end with dot product. Now, the dot product in and of itself doesn't give us a whole lot of information. It does, we'll apply to orthogonal vectors. We'll talk about that when we get down here. But basically, it's important because it's used in a lot of formulas that relate to vectors. So just like 9.4 was all about vectors, 9.5 is all about vectors as well. But it's based on the dot product. So the dot product of two vectors, u and v, has a big dot between it. And it's read u dot v, or the dot product of u and v. And what you do is you take the horizontal components of each vector and you multiply them together. Then you take the vertical components of each vector and multiply them together. And then you add those products. And that is your dot product. Okay? Now this little square gives you a lot of information about dot products and kind of breaks down some different properties and scenarios and things. And I just pulled it right from your book just so that you would have it in case you were curious about some of it, but it doesn't actually directly relate to this section. So I'm just going to leave this here in case you want to look through it. Now, what does relate to this section is this formula that you see right here. This gives you theta, or the angle between two non-zero vectors. So we're back to theta. I know we were in alpha, now we're in theta. And theta is going to be anywhere between 0 and 180 degrees. So we're just in the first two quadrants there. The numerator is the dot product of the two vectors. The denominator is going to be the magnitude of each vector. So for some reason, each little magnitude there is missing a line on each side. So this is the magnitude of u multiplied by the magnitude of v. Okay? Same over here. Okay. Now, I mentioned orthogonal vectors. Another thing that we like to look at with vectors is we like to find out if they have a special relationship between two vectors. So are the two vectors forming a perpendicular situation where you would have a 90-degree angle? That's important. These are called orthogonal vectors. Now, I know you're used to calling them perpendicular, but we call them orthogonal in trig. And if that's the case, then your dot product is 0. So as you are going through, when you see a dot product of 0, you should automatically think, okay, those vectors are orthogonal. Okay. Another way to tell if they are orthogonal is that theta is, of course, 90 degrees between the two vectors. So that's another way. Now, another relationship, and it, besides being perpendicular, would be that your vectors are parallel, like this. So if this is vector A and this is vector B, to tell if they're parallel, you have to be able to recreate one of the vectors from the other by multiplying it by a scalar. And we'll get into some examples of that later on. Another way to tell is if the angle between them is 180 degrees. So that's also a nice little giveaway. Now, of course, in addition to being orthogonal or parallel, there's also the option that there's neither. There's not a relationship of any kind. So that's also a possibility that we will look at. Okay, the last thing are these two formulas down here that are a little more complicated, but we're going to practice them a lot. So in this case, we have two vectors. We have vector v and we have vector w. And what we want to do is take vector v and break it into two vectors, vector 1 and vector 2. So we want to decompose v into vector 1 and vector 2. And then we want vector 1 to be parallel to w, and we want vector 2 to be orthogonal to w. Well, gosh, that's a lot of things to ask, right? Well, these two formulas handle that. So first you find vector 1, which is the one that's parallel to W. To do that, you take the dot product in the numerator of V and W, divided by the magnitude of W squared. This is going to give you a scalar, or just a number, like a constant. And you're going to multiply that by vector W. And we said if you multiply a constant by a vector, the other vector becomes parallel, which is what we wanted. So that's what happens with vector 1. Then, to get vector 2, we just take vector V, the original one we had, minus this new one we created, and vector 2, magically through math, ends up being orthogonal to W. And you can even test that by finding the dot product of V2 and W, and that should give you 0. We're not actually going to do that, but you could if you were really concerned about making sure you have the right answer, and that would allow you to verify that sure enough it is orthogonal to W. Okay, so nothing to really highlight on this first page. Your My Math Lab homework just jumps right into examples, and there are 8 examples, so we've got 8 examples. Let's start with our first example right here. Okay, for the following vectors, here they are, we have vector V and vector W. Find the dot product V dot W, okay? Once we've done that, we want to find the angle between them. Then, given these two pieces of information, we want to know, are the vectors parallel, orthogonal, or neither? Okay, so 3 parts to this question. Let's jump on in. All right, one thing that I like to do is kind of state exactly what that dot product means, at least for the first example. And the dot product of V dot W means A1 times A2 plus B1 times B2. We're kind of back to A's and B's again. I know we keep jumping all around. I'm sorry about that. If you want to call this X1, X2 and Y1, Y2, you can certainly do that. And then I'm going to label. So here's A1 and B1, or you can call it X1, Y1. This would be A2, B2, or X2, B2. Okay. All right. Now we're ready for the dot product. Okay, so part A, I don't know if you can hear that booming around, but the dumpster is being dumped very aggressively by the garbage truck. Okay, here we go. So A1 is A times A2 is 7 minus B1 is 7. Oh, I was supposed to put a plus. I'm sorry. I don't know what made me do that. Okay, B2 is negative 8. There we go. If we clean this up, we have 56 minus 56. This gives us a dot product of 0. Okay, well, hopefully you remember from the first page that we already know then we're dealing with orthogonal vectors or perpendicular vectors. But let's keep going. Okay, for B to find the angle between them, I'm using the formula cosine theta equals the dot product in the top divided by the magnitude of W squared, and that whole thing is going to get multiplied by, whoops, I'm on the decomposition part. Good gracious, I think the garbage truck threw me off. I'm combining formulas with your decomposition formula. Divided by the magnitude of each, multiplied together. There we go, that's right. Okay, we already have our dot product. Our dot product is 0. Okay, so from your knowledge of fractions, do we even need to find the denominator? No, not really. Your magnitude can't ever be 0, so we're not worried about having 0 in the denominator. But we do have a 0 in the numerator, and so I hope you remember that 0 divided by anything, and it doesn't matter what it is going to come out to be 0. Now, if you wanted to find the magnitude of each of these, I will go ahead and tell you that they have the same magnitude. It ends up that each one of them has the magnitude of the square root of 113. So when you multiply them together, you get 0 over 113, which is 0, like we predicted. So we don't actually have to go through and do this because our numerator is 0. Now, since cosine theta equals 0, what you're going to be doing is figuring out where on the unit circle in the first 2 quadrants, where is cosine 0? Well, if you put your calculator in the degree mode, because remember with vectors we use degrees, and you do second cosine or inverse cosine 0, okay, I'm already in the degree mode. I'm going to do second cosine, inverse cosine of 0. I get 90 degrees, which is what we expected. That's my theta. That's what we expected because we already said they are orthogonal. And so if your dot product is 0, you already know theta. It's 90 degrees. You don't actually have to go through any of this, but you can just to verify it. So since we have a dot product of 0 and the angle between them is 90 degrees, these vectors are indeed orthogonal. There we go. Perfect. Okay, let's try another one. Okay, example 2. Same directions here, 3 parts. Okay, here's my first vector, here's my second vector. I'm going to jump on in. I'm going to do my dot product. I do like to label them, so I'm going to do A1, B1, A2, B2. You can always do X1, Y1, X2, Y2. Okay, now I'm going to have A1 times A2 plus B1 times B2. Now watch your signs there. If you see a minus sign, you have to include it as a negative inside your dot product, okay? This is going to give me a positive root of 3. This is going to give me a positive 1. I can't reduce that. That's the best I can do. So my dot product is square root of 3 plus 1. Well, we are definitely not orthogonal, okay? We can't rule out parallel yet, but we are definitely not orthogonal. Okay, let's go on and find our angle between them. Okay, I messed it up last time, so I'm going to write it over for you. Dot product in the top, magnitude of each multiplied together in the bottom. Here's my numerator. Okay, now I'm going to need the magnitude of each one, so let's do that. Magnitude of V is going to be the negative root of 3 squared plus negative 1 squared. Remember, you just take each little piece, each little coefficient of your i's and j's, and you square them and you add them together, right? That's how you end up with the magnitude. Okay, let's clean this up. Negative root of 3 squared is just a positive 3. Negative 1 squared is a 1. This gives us square root of 4. Magnitude of V is a 2. Okay, let's find the magnitude of W. All right, so we're going to take negative 1 squared plus negative 1 squared. We get 1 plus 1. That's the square root of 2. Well, that's the best we can do. So multiplied there together, we get 2 root of 2 in the denominator. Okay, well, this is not on the unit circle. I can tell you that much. So what we have found out is that cosine theta is equal to the root of 3 plus 1 divided by 2 root of 2. This is not something I can look up on the unit circle. Even if I rationalize it, it's just going to get crazier. Luckily, you have your calculator. You want to be in degree mode, and you want to use lots of parentheses. Now I know that you're smart enough to make sure that you close off the top, but the key to this is also closing off the bottom. Now I know you might say, well, why do I have to do that? Because they're multiplied together. It's because when you put this in your calculator, if you don't seal this off, your calculator will put root of 2 in the top. It will multiply it by the whole thing, and you will get an error message. So if you get an error message, you don't have enough parentheses. So here's what you're going to put in your calculator. all right, you're going to put in inverse cosine. Then, you know, it automatically gives you a big set of parentheses. Okay, within this, you're going to put the top set of parentheses. Then you're going to hit divide and put the bottom set of parentheses. That's a lot of parentheses, but I promise you that's going to give you your answer. Okay, so let's try that together. Here we go. We're going to have second cosine. Now that's the automatic set. I'm not worried about it. I'm going to go ahead and make another set for the top. Oh, excuse me. Sorry, I had to sneeze. Okay. Root of 3 plus 1, seal it off. That's my numerator. Divided by, I need another set of parentheses for my denominator. 2 square root of 2. Seal that off. Then close the outside set. So there we go. We have our outside set, then we have our numerator, then we have our denominator. That's so important. The denominator is the one that'll mess you up in this case. I hit enter and I get 15 degrees. All that work for 15 degrees. That's my theta. Okay, well, if this were 90 degrees and this were 0, we would be orthogonal. If this were 180 degrees, we would be parallel. I don't have either situation. So my answer for this is neither. It's neither. Okay, now another way we could look at the neither situation is I could take a closer look at these vectors and I could think, okay, is there anything I could multiply by either one of them? And you'd have to multiply both terms by the same number that would turn one of these into the other. Well, if I multiply this by a positive root of 3, that would give me the I term that I want. But the problem is I would also have to multiply the J term by it, and then I wouldn't have the same one. So we are in fact neither, because there's just not anything I can do to turn one of these into the other, because I have to multiply both terms by the same thing. So that is the situation, okay? All right, example 3, okay? We just have 2 more of these, and the reason I want to keep doing these, I want to show you a parallel one and make sure you're comfortable with it, and then I want to show you one where we don't have all of the components, okay? So same directions. I'm going to write A1, B1, A2, B2 right there. All right, let's do the dot product. I'm going to have my A1 times my A2 plus my B1 times my B2. Okay, this is going to give me negative 63 plus a negative 112. I could have just put minus 112. Anyway, that turns into a negative 175. There's our A. Okay. Dot product, it is definitely not orthogonal, but it doesn't tell me anything about parallel, so got to keep going. Okay, now for B, we want the angle between. So remember, that means dot product in the top, magnitude of each in the bottom. So magnitude of V is going to be negative 3 squared plus negative 4 squared. Okay, that gives me a 9 plus a 16. That is a 25. Square root of 25 is 5. Very nice. Okay, let's find the magnitude of W. We're going to have 21 squared plus 28 squared. Okay, 21 squared is 441. 28 squared is 784. Add them together, we get 1,225. All right, well, would you believe that if you take the square root of that, it's a lovely little 35? Who knew? I didn't. Okay, there we go. All right, so if I multiply 5 and 35 together, Look at there, I get 175. I reduce this down even more, and I get a nice little -1. Look how this is shaping up. Okay, so this is what I'm dealing with. I can look on my unit circle and find where in the quadrants 1 and 2 cosine is -1, or I can use my calculator in degree mode, okay, and I can do second cosine -1. And look at there, 180 degrees. There we go. This means we have a parallel situation. So I already know that's what I'm going to write for C. Now let's look at, though, this situation that was mentioned, how you can tell if they're parallel. Let's look at that situation. If we have the vector -3i minus 4j, and we have the vector 21i plus 28j, is there a scalar or a constant that we could multiply by one of these that would give us the other vector? If there is, that's another indication that they are parallel. Well, I notice if I look at this smaller one here, if I multiply both of these terms by a -7, I get these. So 7v, if I multiply 7 by v, oh, it's supposed to be a -7, isn't it? Sorry about that. Okay. All right. And then I distribute it through, I get 21i plus 28j, which just so happens to be vector w. So because I can multiply a -7 by both terms, that's another indication that these guys are in fact parallel. All right, last one of these, and then we're going to do some other vector stuff. Okay, I know you've got the hang of this. The reason that I wanted to do this one is because if you look, these vectors are not complete. Okay, they are not complete. So if I am writing out A1 and B1, and I am writing out A2 and B2, I'm going to have some zeros in there. I don't have an I component for V, so my A1 is 0. My B1 is 12. I do have an A2 component for W, it's -1, but I don't have a J component, so B2 is 0. Okay, so let's find our dot product. We're going to have A1 times A2 plus B1 times B2. Our dot product is going to be 0. Okay, now that we know it's 0, we automatically know the angle between them is 90 degrees. And we automatically know the relationship is orthogonal. And we can zip on right through. Now, if you wanted to see that play out, if we do cosine theta, if we put the dot product in the top, again, that's going to automatically give us a 0. Now, if you wanted to know what these magnitudes are, magnitude of V is 12, magnitude of W is 0, still going to give you a 0. Inverse of cosine of 0, there's our 90 degrees like we predicted. And because of both of those situations, we are in fact orthogonal. Now, this doesn't always produce orthogonal when you have these components like this, but I just wanted to show you, what that would look like and how to maybe make it a little faster just by using your knowledge of vectors. Okay. All right. Let's go on to number 5. All right. Number 5 gives us two vectors. Here's vector V, but look, we're missing the vertical component. Instead, they put in a -a in its place. We do have a complete W vector, and we are told they are orthogonal. This again means you have a dot product of 0. And then I know this is kind of hard to read, but what it wants you to find is A. It wants you to find this little guy here. Okay, so what we're going to do is set up a dot product. Okay, so we're going to have this first component, which is 1, times this horizontal component, which is -2, plus this vertical component, which is -a, times this vertical component, which is -3. Okay, and we're told that because they're orthogonal, this equals 0. So what we're doing is creating an equation. 1 times -2 is -2. -a times -a is 3a. And now we're just going to solve for a, just like we would in algebra. So we're going to add 2 to both sides. We get 2 equals 3a. We're going to divide by 3. And sure enough, we get a number for a. There it is. We don't have to include the negative because that didn't come along with the a, right? That was already here. So you just want whatever comes out of your equation. Don't change it in any way. Okay, the last 3 examples are all the same situation. They all want you to decompose vector v into 2 smaller vectors, where the first one's parallel to w and the second one is orthogonal to w. Okay, and if you recall, that's the little bottom rectangle on that front page where we take the dot product of the 2 in the top, the magnitude of w squared, and we multiply it by the vector w. This was the equation I was trying to use earlier. And then vector 2 is going to be the original vector minus v1. So these are the equations we're going to do this, okay? All right, I'm going to label these because I'm going to have to find a dot product, okay? So v times w is going to be 12 times -1 plus 4 times +1, okay? Find the dot product of that. I get -12 plus 4. That gives me a -8, okay? The other thing I need is the magnitude of w. So I don't have to find the magnitude of both, just w. So I'm going to take -1 squared, +1 squared. I'm going to get the square root of 2. Okay, let's find v1. So dot product in the top, magnitude in the bottom, and we're going to square that magnitude. Then we're going to multiply that by vector w. Okay, so I'm going to have -8 over root of 2 squared is 2 times vector w. This is going to be a -4 times vector w. Okay, so I'm going to distribute this -4 through here, and vector 1 is going to be +4i minus 4j. There's vector 1. Okay, and it's going to be parallel to w because here was w and we just took a scalar or a constant and multiplied it through. And remember, that's the definition of parallel. So we know he's parallel. Okay, now let's find v2, which is supposed to be orthogonal. So I'm going to have v2 equals v minus v1 that we just created. Now notice I put v1 in parentheses. That's because remember, when you subtract anything with multiple terms, you have to distribute a negative through there. So what this actually means is 12i plus 4j minus 4i plus 4j. Don't forget, you have to change those terms. This is going to give you a vector v2. Now we're just going to combine like terms. 12i minus 4i is 8i. 4j plus 4j is 8j. And there's vector 2. Then if you wanted to check, if you take vector 2 and do a dot product of it with w, you're going to find that that dot product is 0. So this is orthogonal to w, just like we wanted. But these are your 2 answers. Okay, and they came out really nice. Probably too nice, right? Because you know what's coming next. Here are the last two examples. My paper's kind of pulling away from me, so I'm gonna fold it. Okay. These are gonna get a little ugly. So, with fractions. So we just have to make sure you're comfortable with fractions. I know you're not. We're gonna pretend you are. You can do this. Okay, same directions. So remember, first thing we're gonna need to do is find the dot product of V and W. Okay, so I'm gonna label. I'm gonna have -1 times -2 plus -6 times +1. So it's gonna give me +2 minus 6. My dot product is -4. Okay, now remember I need the magnitude of W, not of V, just of W. I'm gonna have -2 squared plus 1 squared. This is gonna give me a 4 plus a 1. My magnitude is √5. Okay, now I'm gonna put this together. So vector 1 is going to be the dot product divided by the magnitude squared times vector W. There we go. Okay, let's clean it up a little bit. I'm going to have -4. Square root of 5 squared is 5 times vector W. Okay. So now we just need to distribute this right through here. Vector 1 is going to be a +8/5 I minus 4/5 J. There's our vector 1. Okay, we're just multiplying -4/5 right through that vector. All right, here's where you have to have your fraction skills on point. To get vector 2, we're going to take the original vector V, and we're going to subtract vector 1. Now remember, I'm going to put him in parentheses because I have to distribute a negative through here. So I'm going to have to push that negative through. This is going to give me, oh, before I do that though, you know what we could do to save ourselves a little room since I'm running out of room? You know I'm going to have to combine these terms with these terms. These have a denominator of 5. These have a denominator of 1. I'm going to need them to all have a denominator of 5. So let's kind of pull these off to the side and think about this. This coefficient is -1. Okay, I want it to have a denominator of 5. If I multiply top and bottom by 5, I get -5/5. Okay, perfect. -5/5 I. Good. Now I have -6/1. I want him to have a denominator of 5. So I'm going to multiply top and bottom by 5, and I get -35 J. Then I can go ahead, distribute that negative through, and I have the same denominator for everything, and I'm able to combine these a little easier. Okay, so V2 is going to be -5/5 I minus 8/5 I. That is a -13/5 I. My J's are -35 plus 4/5. That's a -26/5 J. And there's my V2. And of course, you could check this by doing a dot product with W if you wanted to. All right, let's try that one more time. Okay, one more set of these fractions to make sure you're comfortable. Same directions. We're going to do a dot product between V and W. I'm going to go in here and label. I'm going to get 4 times -3 plus 1 times -1. This is going to give me a -12 minus 1. My dot product is a -13. Okay, now I need the magnitude of W. I'm I'm going to take negative 3 squared plus a negative 1 squared. This is going to give me 9 plus 1. That's a square root of 10. Okay. Now I'm going to find V1. My dot product is my numerator. I'm going to have square root of 10 in the denominator, but I got to square it. And then I'm going to multiply that by the vector W. Okay, we'll clean this up a little bit. We get negative 13/10 times negative 3i minus j. Keep going. We're going to distribute this through here. We're going to get a positive 39/10i plus 13/10j. And that's our vector 1. They just keep kind of getting uglier, don't they? This is our vector 1. Okay, last part. To get vector 2, we need the original vector v minus vector 1. I stuck I up there in the numerator. You can if you want to. Some books do that. Okay, before I push this through, we know what we have to do. We have to take these two terms and give them denominators of 10, okay? So if I have 4 over 1 and I want a denominator of 10, I'm going to multiply top and bottom by 10. I get 40/10 I, okay? Here I have 1 over 1. I can make that 10/10 j. So if you need to come off to the side and kind of do what we did and make two equivalent fractions, you can do that. I'm kind of out of room, so that's why I just thought we'd do it in our head. But make sure that you have denominators of 10 here. Now I'm going to subtract 39/10 I, and I'm going to subtract 13/10 j. Can you still see that? Okay, good. All right, then we're going to combine. So 40/10 I minus 39/10 I is a positive 1/10 I. 10/10 j minus 13/10 j is a minus 3/10 j. And there's your vector 2. And ladies and gentlemen, we're done. That's it. I don't know why I have a blank paper back there, but we did it. Okay. Your next job then is to finish up my math lab and then get ready to study for test 4. So I will post your study guide very, very soon. Miss you. Bye.